Not because they are easy, but because they are hard.
I know if you go on to Math 110 at least, you're going to have to be able to find points of intersection of two graphs, whether they're lines or parabolas or whatever. So I'm going to go over it.
Allow me to demonstrate.
Let's get right to a problem, and then we'll review kind of what we did. Okay, I've got two equations here.
I know that, dude.
And these ones happen to be lines. They're going to intersect in exactly one point in this case. Now, other type of graphs may intersect in more than one point, but in this case we're looking for one point, and remember that one point has two values, an x and a y. So we'll start off by solving one of the two equations for one of its variables. You get to pick whichever one you want, whichever is easiest. Now in this case, I think the blue x is the easiest because it's already solved for x. Okay, so I'm going to choose the blue x, and then I'm going to do step B, and that is to substitute the expression equivalent to that variable, 3y, into the other equation. I'm substituting it instead of x. When I say the other equation, I hope you know I'm talking about the green one. So, let's substitute 3y instead of x into that green equation, and we'll get an equation
Hey, that's just crazy enough to work.
with only one variable, only y, which we can solve for. 3y plus y is 4y. If 4y equals 20, and I divide both sides by 4, I know y is 5.
Is that your final answer?
Well, remember, I'm looking for a point of intersection, and a point has an x and a y. So I'm kind of halfway there, because I've found the y, but I still have to find the x. So but I have more information now, you see. So what I'll do is take the value of y, which is 5,
Excuse me?
take the value of y, which is 5, and substitute it in to the original equation instead of y. So instead of y, I'm going to write 5. And now I have an equation with only one variable, and it's the other variable, x,
Hey, this is great, man.
which I can solve. And x will be
Could it be?
x will be 15. So the solution to this system, if you would, more than one line, is the point where x equals 15 and y is 5, or sometimes we write the point 15, 5. Not so bad, and we did it without looking at the graphs, which is pretty cool.
Wait a minute.
Since I went to all that work, and I know this works in the blue equation, I just solved it,
I can do that, but I don't want
it
to.
would probably behoove me to check it in the other equation, the green one. Doesn't take much work, does it? Let's put 15 in for x and 5 in for y, and just make sure.
You are correct, sir.
And I know it works. In fact, I know this is the point where they intersect because this pair works in both equations, and that's the only point that works in both equations, the point where they intersect.
What happened?
Well, let's go over what we did.
If we keep this speed, we'll blow up any minute now.
Pay attention. First thing we did was we solved one of the two equations for one of its variables, whichever was easiest. Then we substituted the expression equivalent to that variable into the other equation, and that created an equation with only one variable that we could solve, and we did that. We solved the now single variable equation created by step B. That gave us more information. It told us what one of the variables was, the value. So we substituted that value that we found in step C into either of the original two equations and solved for the other variable. And then don't forget,
I can do that, but I don't want to.
check your proposed solution. Check your x and your y into both equations. Make sure you didn't make a mistake. If it doesn't work in both equations, you haven't found the point of intersection. Okay?
Do that again.
Okay, this time, let's do it with two graphs or two equations that are not lines. The blue one is going to end up being a parabola, and the green one
I know that, dude.
is a line because it's of degree 1. There's no exponents. Okay, so we should have, well, we don't know how many points of intersection we'll have. We could have more than one, though, is the point. So, let's begin by solving one of the two equations, either one, for one of its variables. It doesn't really matter which. The green equation looks easier, and probably I'd solve for x, but I want to show you that there's no really wrong answer here. I mean, as far as which to solve for. So this time, I'm going to solve for y, just from habit. I'm used to solving for y. So let's see, I'll subtract x from both sides. And then, that's a negative y. I don't want negative y, I want y. So I'll divide everybody by -1, and y will equal x minus 1. That's the first step, to solve for one of the variables. Step B is to substitute the expression equivalent to that variable, which in this case is y. The expression equivalent to that is going to be x minus 1, and I'm going to substitute it into the blue equation. Instead of y, I'm going to put what y is equal to, x minus 1. Now that creates an equation that I should be able to solve.
Now what am I going to do?
Well, this is a quadratic equation because it has an x squared. But we know how to solve a quadratic equation, but we also know that we're probably going to get two answers.
Hey, that's just crazy enough to work.
Let's do it. If I distribute that minus 3, I get x squared minus 3x plus 3. Recall, a negative times a negative equals a positive. Now let's begin by getting a 0 on one side. So I'll subtract 1 from both sides, and I'll get x squared minus 3x plus 2 equals 0. Now remember, one way to solve a quadratic, if you can do it, is to use... Okay, so let's factor. And I see that there are two answers here using the 0 property. What do we make x equal to make this factor 0? That's going to be a root.
Darn tootin'.
One of the answers is that x equals 1. Now in this one, the other answer will be, what makes that equal to 0?
I'm dangerous. I'm very, very dangerous.
X equals 2. Now these are both x's. So it looks like I'm going to have 2 points of intersection. One of the x's will be 1, and the other x will be 2. Now I need to substitute, I'll do it separately, each of those x's into the other equation and find y.
I don't understand.
Well, since I have 2 points of intersection, I have to do 2 separate substitutions. So I'll put 1 in instead of x and solve for y. Subtracting 1,
Hasta la vista, baby.
I get negative y equals 0. And if I divide by -1, y is 0. So in that case, I end up with the point 1 for x and 0 for y. That's one point of intersection. If I put a 2 in for x and solve for y, let's see, subtract 2 from both sides and then divide by